Welcome to the latest Cimteq webinar. Today's webinar is called Effective Scrap Reduction and Material Management with MES. I'm delighted to be joined by industry expert Bill Pearson, Amanda Shehab, Director at Cimteq, and Hamada Khalifa, Commercial Technical Lead at Cimteq. Before we start, I'd like to draw your attention to the chat box, which you should see on the right-hand side of your screens. If you have any questions about the topics covered, please do use the chat box function, and we will endeavour to answer all questions during the Q&A section at the end of the webinar. But if we don't get to your question, we'll contact you after the webinar. You should also see a handout section where you'll find the white paper that has been created for this webinar. Please download it and enjoy it at your leisure. Lastly, this webinar is being recorded and you will receive a link to the recording later on today. So we thank you for being here today, and without further ado, we'll get started and I'll hand over to Bill Pearson. Thank you, Bill.
Thank you, Ken. Welcome, everybody. My role today is to set the context. I'd like to start by talking about money, because materials forms a significant part of the cost base of cable businesses, as you all know, but I just wanted to put the money in context. In 2021, Prismium, in its annual accounts, said that its EBITDA was 7.7%, so its costs were 92.3% of its sales. So costs are a big part of cable making, and manufacturing costs and materials is the significant proportion, probably 70 to 80%. That goes up for commodity cables by a few percentage points, and for specialty cables it might be a little bit less, but still significant amount. So we're talking about a big cost, and a small changes in our scrap and in our overusage of materials, say 1 to 2% on scrap or 5 to 8% on overusage, over and above that which we would expect to see in our costings, would wipe out our profit. So it's, as one of my consultants used to say, it's the difference between two very big numbers, and when one of those big numbers moves a small amount, it has a massive impact. So it's very important for all cable businesses to have absolute control over their materials and their waste. I've identified two categories of waste that I've worked with in the past. Hopefully you'll recognize them: scrap and overusage. I just want to talk about those two separately. Scrap is generated when we have out of specification or degraded raw materials in our stores. So they don't even hit the shop floor, they just become out of date, damp, rusty, whatever it is. But if we're not looking after our materials when there's stores, they can end up as scrap. We are all aware of startup and shutdown waste at each process, particularly extrusion, but also the lengths that we lose as we go through the cable making process that ends up in skips on the shop floor. We could produce non-compliant semi-finished components that don't meet the required quality standards. And then we would be in a quality process where either we're looking for approval to proceed or rework or scrap. We get leftovers between each process, either unused polymer, unused fibre or unused wire, often in short lengths. But again, those leftovers end up in the scrap bin as scrap. We could, if hopefully we don't, but we could produce totally non-compliant finished product, and we might have to either rework it or scrap it. And then that starts to get expensive, because as you know, we've added a lot of cost to those materials to build the product. It could also affect our service, and we could get test failures, and cables could be over or undersized or too short. A customer might have specified a specific minimum length, and we might have ended up producing a cable that's shorter, no good for them. We've got to remake, and the one we've made is scrap. Scrap is usually visible. It's in skips, you can see it, and it can be weighed. That's one of the characteristics of scrap. Overusage, on the other hand, tends to be hidden. Can be a bit of a mystery and can get spotted too late. Overusage can actually start at the design stage. We could over-design a cable in excess of the requirements of a customer. So we could actually have leaner designs sometimes. So we could be building in materials into our designs. That's something for the cable designers and the technical guys to get their heads around. When we're manufacturing, we could make things too thick. We could make things too great a diameter. We might not be compacting the cables enough. They could just get too big. And as you know, cables, as you start to construct them, the layers get bigger and the overusage on the outer layers. Even if you get the radial thickness correct, you might still have an overweight sheath. Over lengths applied to the customer, it's an interesting one. If a customer wanted 500 meters and we just send him 525, it doesn't seem a lot, but we've just given away 5%, and that's straight off our bottom line. So overusage is generally hidden, scrap is usually visible. If the level of scrap and overusage included in our costings is too high, that is, if we don't know enough about our scrap and overusage and we make too greater an allowance, then our costs and our prices for our cables will be high, we could be uncompetitive, and ultimately we could be unsuccessful. So having a really good handle on how we're using our materials and controlling them is vital for any cable maker. Cable making comes in many different forms and many different styles. Our cables can be high volume repetitive cables, standard designs, millions of meters of the same thing, or at the other extreme, low volume manufacturing. That's just how I've chosen to split cable manufacturing, just to try and make it a little bit simple for today for this presentation, because it does impact on how we manage materials. In a high volume environment, it's very price competitive. So there's a strong need to manufacture towards the bottom end of specifications wherever possible, and to engineer cost out of our designs and out of our manufacture. These are also typified by long runs with few changeovers that still need to be slick and efficient in their wastage of materials, but they're less frequent than in the other type of manufacturing. Often they're in standard lengths, either in a single manufactured length or many drums cut from a single length. But we can still end up with leftovers and pieces at the end in terms of scrap. They are usually typified by minimal leftover materials between processes, because we tend to run out the copper, run out the plastic, run out the aluminium, start a new batch. So we don't tend to have that much waste on materials, but you could on conductors. High volume manufacture really does set itself up for for statistical analysis and standardized approach and automation. And I know many of you invest in those things, but we should be really thorough analyzing our statistics, absolutely on top of our material usage, our overusage, and our scrap in a high volume environment. In a low volume environment, it's a little bit different, or can be. The customer's coming to us for our design technology typically, because these might be unique cables, industrial cables, mining cables, control cables, something that's a bit different, could be a one-off. Often for them, lead times are important, and accuracy of delivery dates is important, because they're often building a project. So our cable has to arrive in line with their project lead times and project schedules. Price is often lesser consideration, still important, but lesser than maybe those two things. These types of designs are typified by shorter, often custom lengths, one-off designs, and limited repetition of cable design. So you haven't got the same ability to necessarily improve continuously as in the high volume manufacture, but you've got to absolutely be on the ball making this right first time, and that's the next bullet. Right first time is important. If we don't and we have to remake it, we've obviously not going to make the money we hope to on that contract, but we could also have affected the lead time and the delivery date, which could ultimately become a big problem commercially for the business. So making sure that we're error proofing our manufacture and making sure we get it right first time, absolutely crucial in low volume manufacture. Material waste can be less of a priority, but oversized tables could be unacceptable. If it's too great a diameter, it might not fit through a gland into a cabinet, or it might not have a bend radius it's required to go into a machine, for example. So all these users' requirements have to be met by the design and met by manufacture. And therefore, progression of manufacturing versus the design is absolutely critical through the process. So the priorities for material management and scrap do vary within the cable industry. And there are many variants and a rainbow of different types of cable manufacture. I've just been a bit digital there and talked about two. Good material management requires good control. And I've said here control of production processes and control of production. I've just split them just to emphasize a few points. In terms of controlling the process of production, the point at which the material is converted into a subcomponent or a cable, we have to make sure that we're using the correct input materials and the correct semi-finished products. We could well have lots of things on the shop floor that look the same, but have been set up for specific orders. And if operators select the wrong length of conductor or the wrong insulated core, then we could be either end up with a short length on an order we're going to make, and equally then we've also used something that was due for another order, so we end up with a remake for that. So having good traceability of length through manufacturing is important. We've got to make sure that operators have got very clear instructions and very clear quality instructions about how to set up the process, how to monitor the process, how to monitor quality during production, and how to record their data. And if they see a variance, they should be seeking assistance. And absolutely recording all information accurately. And supervision here, in terms of control of production, there's an overlap here. Supervision's got an active supervision responsibility to make sure that operators are actually doing those things to the required standard. And that's just a simple walking around, checking, maybe repeating some of their measurements, because people do what you review, and making sure that we're getting the right data for the production processes just ensures that we've got the right information on which to understand our material usage. Controlling production is more for the production supervisors and for the production managers. So making sure the required tooling is available and it's within tolerance, and that all materials available for the shift. That's the organizational side of production. We don't want the operators having to hunt for things urgently and then finding the wrong thing and using it. So really got to make sure that it's a very controlled, very visible environment, and that's the responsibility of production and supervision. They have to supervisors have to ensure that process operators understand the objectives for their shifts, what we're supposed to be doing today, what sequence we're supposed to be doing it in, and what we're expecting in terms of performance from them. Use trained staff. Sometimes, unfortunately, we get to a situation where we might use someone who's not fully trained on a particular process. That can lead to errors. Clearly, that could lead to scrap. It could lead to overusage. But it does happen. But again, making sure that staff are trained is a responsibility of supervisors and production managers. When variances occur, supervision and management really has to react quickly to it, and if necessary, stop production. There's no point carrying on making scrap if we're just making length for the sake of making length. Reacting to variance is important. Checking that information is accurate. If the operator's measured a radial thickness and recorded it on his sheet, a supervisor might want to take another sample and just check it, for example. Or check the sample that the guy or girl cut and put onto their shadowgraph or whatever instrument it is they're measuring it. Just making sure that people know that we're keeping an eye on what they're doing means that we really are in control of our material consumption. And it's the role of supervision and management particularly to look for opportunities for improvement. So they should be looking at the data, they should be looking at their waste, and should be identifying where things can be improved. Both operators and managers have a role to play in good materials management. Some basic critical success factors, just trying to boil that lot down a little bit. So minimizing overusage. Design to the minimum possible based on the process capability demonstrated within your plant. Update this over time. So if we have a particular process capability and we have to make a radial thickness a little bit bigger than the minimum because we don't want to infringe the minimum, then that's fine. But if we improve our concentricity or we improve our control and we're capable of reducing that down towards the minimum, absolutely we should be doing it. Use inline measurements and feedback control wherever possible. It's a statement of the obvious, but have we got diameter measurement? Have we got radial thickness measurements online? Are those instruments working? All those good things are just basic fundamental cable making, but it's surprising how often it's the case that those things either aren't working or are on the wrong machines. Gather data, analyze it, learn and improve. We should spend as much time on materials as we do, say, on manpower productivity, which sometimes gets a greater emphasis, even though it's a lower cost. We really should be spending our time looking at our material usage and our scrap and identifying opportunities to improve. A particular one is understanding length optimization in your specific processes. This is when we start off at the beginning with 1,030 meters, we end up with 1,020 meters at the next process, 1,010, and we're making a kilometer for the customer. Just understanding your particular environment for your designs, and the losses in length can save an awful lot of materials. And react quickly to variances. Absolutely, every time if we get unexpected scrap or unexpected overusage, we need to take action, because the best time to stop material waste is at the point that it's happening. Minimizing scrap, obviously investing in quick changeover techniques for different types of machines. You'll all be aware of what those are. But again, when it's economic to do so, it's not always economic. So if it's not, how can we improve our changeovers to reduce our material waste without those technologies? Planning does play a huge role in reducing scrap in terms of the sequencing of cables through the day to minimize changeovers, particularly on extrusion, as you know, around color changes, polymer changes, and elastomer changes. Those are where most scrap gets generated, and planning and scheduling has a huge role to play there in streamlining those losses. Ensuring that the correct raw materials and semi-finished products are consumed. Again, I mentioned that earlier, that's a basic in terms of making sure that operators are using what we expect them to use and want them to use, rather than something that they decide that they think is best to use. Understanding length optimization, again, helps to reduce scrap. Ensuring quality control and quality management steps are being adhered to accurately. Important active supervision from supervisors to make sure that operators are recording accurate data and that we really do get good information, intelligence about what's happening on the shop floor and reacting quickly to variances. Material management has to be part of an integrated approach to production scheduling, technical management, quality management, and stock control. That all works together to give us control of our materials. And if you get to an accounting period end and you've got a material and the stock control, the stock take is done, and the finance department says you've got a big negative variance on materials, where's all the materials gone? There should have been another 50 tons of copper in the stores and another 40 tons of polymer. Where's it gone? If that's happening regularly in your business, then you haven't got control of materials, and you really do need to get a strategy for getting control. That's me setting the context. I'll now hand over to Amanda, who will describe how the products from MES address some of those issues. There you go, Amanda.
So thank you very much for that, Bill. So I'm going to continue now, and I'm going to do a short introduction to Cimteq products and talk about what we can do to help to solve some of the issues that Bill has been talking about. So we in Cimteq we have two main software solutions. The first being CableBuilder for cable design and quotation, and the second being CableMES for manufacturing execution. So in terms of CableBuilder, it's an extremely flexible solution. Designed, you can use it for designing all types of cable across all sectors, from the simplest to the most complex. I can be using a single plant environment or indeed a multi-plant environment, and it manages all aspects of plant data. So it's data for the product data, but also process data as well, the process data that is required to actually run the machines to manufacture the cables. It has automatic calculations for all the parameters required in the construction and the manufacture. So for example, things like dimensions, weights, bill of material, running speeds, etc. Anything you can imagine, all these can come from CableBuilder. And in essence, CableBuilder really provides the core information that's essential to have better scrap management and a more efficient material management. It really is the benchmark that gives us the parameters that we need to manufacture to. So without something like CableBuilder and having such a benchmark, we don't actually know how well we are doing. So CableMES, it's a manufacturing execution system, but it is designed specifically for wire and cable. Wire and cable manufacture is quite unique when you compare it to many other manufacturing types of manufacture. I think really this comes down to the fact that we're dealing with length, and length changes from process to process, and then we're transporting that length from one process to another process on drums around the factory. And this really does come up with a unique set of challenges that we have to overcome to have a manufacturing execution system for cable. And with CableMES, we have done that. So CableMES really tracks and documents the transformation of raw materials into finished goods. That's what it is doing. And to do this, it needs to monitor and control the wire and cable production in real time. And what MES is really doing in the context we're talking about today, it's providing the core measurements and controls that we then can compare to the benchmark to actually give us information on how well we are doing. So let's have a look how all this fits together. So this is one possible configuration that the complete factory solution would look like. We have the ERP system here. It doesn't really matter what ERP system you use. The ERP system is really running at the business level. It's running from the business perspective. And it's a bit disassociated really with what's actually happening in the plant. So we have CableBuilder alongside here. CableBuilder sort of stands on its own, but it provides a key role in delivering information to the ERP system, such as the product and bill of material data. So this can be used in the ERP system for costing and also for scheduling. As well as providing information to ERP, CableBuilder also provides information to CableMES. So in order to function, MES needs to know detailed information about the products that we're making, the tolerances that define good cable, the speeds that we should be running, and it needs very detailed information in order to perform its task. And this is all provided by CableBuilder. So CableMES, we've said that it integrates to CableBuilder. It also integrates to ERP. So it takes from the ERP system, it will take a schedule of work with due dates, and it will be given materials from which to consume to produce the required orders. So CableMES in a way is the glue that holds the system together. It operates very much from the plant perspective, and it closes the loop between the high-level business functionalities that occur in ERP and what's actually happening real time on the shop floor. So CableMES, again, in order to do its task, it needs to be closely linked with what's happening on the shop floor, and we will do this through some sort of IoT platform that gives us connectivity to all the devices, the PLCs, the gauges, the controllers that exist on the shop floor that are controlling those machines. Then through the IoT platform, CableMES has access to all this information. And it's a two-way link. So CableMES, with all the information it has, effectively the data coming from CableBuilder can be used as a recipe. So the data in CableMES can be downloaded to the machines to for set points for diameter control or temperature controllers or any such thing like that. And conversely, as we manufacture cable, then all the parameters that we are reading in are stored back in the system, and these are what can be used to compare later, well, in real time as we're manufacturing, but also for historical analysis later, how well we're actually doing against how we expected to do. So this webinar is actually focusing on MES, so let's have a bit of a closer look at CableMES. So any MES system will do a huge amount of things, and different plants will probably have different focus on what they want their own MES system to do. CableMES indeed does a huge range of things that we would not have time to talk about today. But for our purposes, what we do, as in Cimteq, we call it the 4 pillars of MES, and we break it out into these 4 areas to try and explain all the things that the system is trying to achieve at quite a high level. So the first pillar is order execution. And order execution, in simple terms, it's all about delivering to length, delivering on time, while minimising the WIP travelling across the shop floor and minimising waste. So, of course, excess length is waste material. A short length could indeed be scrap. WIP, of course, is a material. The drums moving around the factory is a very expensive material, and we need to keep a close eye on that. And scrap, of course, is one of the many forms of waste. So production performance, this is all about avoiding slow running machines, minimising bad quality product, and minimising machine stoppages. And this really is all about OEE. So if in an ideal world, to achieve 100% OEE, that means that every machine needs to be running 100% of the time that it's planned to be running. And when it is running, it needs to be running at the speed it is specified to run for that product. And when we're running, we need to make 100% good quality. Now, 100% OEE is just not possible in any cable manufacturing plant. The way that we operate is just actually impossible to achieve 100%. But we need to strive to get as close to the actual practical maximum as possible on every machine that we run in that factory. And the good management of good quality management, minimising scrap, and good material management is key to achieving good production performance and higher OEE figures. Moving on to product quality, I think product quality speaks for itself, why we need good quality product. But with CableMES, how do we know it's good product? What defines a good product? And we do this through rigid quality plans and test procedures. So we know exactly what good quality is. And so we can measure that when we're producing cable. We're measuring the quality of the cable, and we're able to identify bad products immediately. And that means we either stop or we correct the issue and continue manufacture. If bad quality product is made, then we need to stop adding value. We don't want that product to proceed any further. So we stop adding value to the product, and we stop consuming materials as it would progress further until it's been checked to see whether there is really a problem or not. Finally, on the last pillar is material management. And this is all about ensuring the correct materials are available at the correct time, in the correct place, and in the correct quantities. Along with that, again, we need to minimise WIP and minimise waste, and very importantly, to ensure traceability. So every raw material and every intermediate, the drum that feeds into the next process, has to be tracked, and we need to know when the cable leaves the door, all the information about the batches and items that have gone into that finished cable. So CableMES, all these things I've just described, CableMES helps to achieve all of these. That's what it's designed for. It's designed specifically to help deal with all these issues. So let's just to pick on a few topics to look at some things that we can focus on. So with CableMES, bad product is minimised. So rigid quality plans and defined tests easily identify what is a bad product, and automatic alarms from the machines and devices also help this too. So bad product is minimised. Actual scraps should be as expected. So the expected scraps will come from the benchmark as of CableBuilder. Every process for every product will have some expected amount of, startup scrap, shutdown scrap, or, bleed, or whatever it is. But with CableMES, all these types of scrap are measured. So any scrap that is produced is measured and recorded. So we can actually compare scraps produced to the actuals, to the ones that we expected. And if there's a discrepancy, then this can be identified and looked into and resolved. So finally on here, leftover raw material scrap is minimised. So in CableMES, all materials are tracked with the quantities and locations known in real time. So any small leftover batches can therefore be minimised or joined together, or all materials are visible where they are, so things can be moved around in order to minimise the waste of leftover raw materials. So moving finally on to material management, and just picking up some points here. So with CableMES, order execution is optimized. So material availabilities and quantities are tracked in real time. We know everything will be available at the right time, in the right place, with the right quantity. So this can be seen in advance, so we can make sure that order execution is not blocked because of missing materials, and things can progress through the factory in as optimum time as possible. Less materials are used, so all material consumptions are measured and can be compared again against the benchmark. So any variances that are found to what we're expecting, it can be investigated and again resolved and improved. The cost of WIP is reduced. So WIP is tracked as it moves through the factory. So every drum that is produced off the back end of any machine is tracked, and a location is monitored, and so we know exactly what the product is, how much length is on the drum, so we can even cost it, you know, in real time, how much WIP is on the floor. So expensive WIP items are, you know, easily visible and can be expedited through to get that cash back. Finally, traceability is built in, so all material batches and WIP items are tracked in real time using barcodes. So everything is scanned as it goes through the factory. So traceability is built in from the raw material right through to the finished good that is delivered to every customer. So that's the end for me. So I'm now going to hand over to Hamada, who's going to go through some of these points in a lot more detail. So let me just hand over control to Hamada. Okay, over to you.
Thank you, Amanda. Thanks to Bill. And thanks to all who are with us today. So let me share with you my screen, please. So today I will describe more, add more information about the scrap reduction and material management as described by Bill and Amanda. So first of all, I will take you in the journey of describing more the scrap types and level of the scrap. We have out of specification scrap, and I'm going to focus more about out of specification scrap, startup and shutdown scrap, non-compliant scrap, leftover scrap, testing, and non-compliant for finished goods. So we have two non-compliant for the semi-finish and the finished good. And as you can see here, a couple of pictures that the scrap, we see it daily, weekly, monthly in our units, and how value it is. So we'll come back to describe and focus more about the scrap or out of specification scrap. Out of specification scrap, yes, as described by Amanda, we have two systems or two solutions that Cimteq could provide you, could help your organization and business on it. We have the CableMES, which is the main robot that controlling the shop floor in terms of respecting the specification, following exactly what is receiving, or following exactly the same information or the input from the CableBuilder enterprise. So the CableBuilder enterprise will play a big role to describe initially what has to be done in the shop floor. So with a good harmonization between CableBuilder enterprise and CableMES, we ensure that what we have done during the costing and during the quotation and what we have got based on that as an order will be implemented and produced well in the shop floor using both robots, the robot controlling the technical costing, technical costing and sales department, and the other robot which is controlling the shop floor team. Startup and shutdown scrap, also this one could be organized and described well in the CableBuilder. So in the coming slide, you will see how the flow of data between CableBuilder and CableMES will move in terms of material, bill of material, operation, setup, running time, and so setup and speed, as well as the scrap. So the scrap in different ways, and also it's a platform. You can describe what you want. You can, if you want to describe only one single scrap, double scrap, whatever, any kind of scrap that you would love to describe it in the CableBuilder Enterprise, the flexibility of the system will help you to describe that. And this information, as I said, will flow from CableBuilder to CableMES. And last but not least, the main message in the slide is no room to waste. No room for us to waste material, and no room to violate the standard. Then the coming one, we have non-compliant semi-finished product and finished product. The problem is if you go further to finished product, then the cost of scrap will be higher. But for the semi-finished product, still the cost or the losses could be managed. And this one is the option, or this one is the function, the main function of CableMES as described by Amanda. When we come to the flow chart, it's similar to the one provided by Amanda. We have the two systems, and we have here, just a moment, let me put the pen. We have the two systems. The first system where we are going to design the bill of material. We are going to describe the routing parameters in terms of which machine I'm going to use, what will be the speed, what will be the setup time, how many operators, and so on, and what is the expected cost behind each and every operation. This one is described in the CableBuilder Enterprise, and then we will have the CableMES where we will see now the flow of information between the both systems is on. You will see two different colors of arrows. The black color is a theoretical information where it's coming from the CableBuilder, the theoretical part, and you will see the most advantage option that we have in CableMES is a feedback. From the real life to theoretical life, and how the real life will challenge the theoretical life, and how you can compare both. If I'm producing well, matching to the standard, or if I'm losing, or if I'm saving. So in both ways. Then the production order, the operation parameters, bill of material, quality control chart, and one of the most important module that we have in CableBuilder Enterprise is quality control chart, where it will challenge and will judge and it will control what is produced by the operator in the machine, in terms of thicknesses, in terms of resistance. I mean resistance, instead of producing a hell of quantity or big quantity for copper or metal, whatever metal, and you find that the resistance or the setup parameter or the leylays or whatever it is not matching with the theoretical one, then the CableMES will play the big role to stop and catch all those parameters, the not well-defined parameters or not well set up parameters. Then you will see also the green arrow where we have the real life going back to theoretical life, and will challenge what we have designed initially. And last but not least, here in this slide is this big portion of historian data. Today I'm producing, for example, I produced a cable 2022 with one parameter, operation parameter, and bill of material. After 3 years, it will be easy for me to go back to see what I have done 3 years ago. So if the operator try to use over quality or minimize the quality, going below the specification, the system will be a guideline for him. The system, I mean CableMES, will be a guideline for him to tell him, yes, Hamada, you are doing something good, or you are violating the standard, and the result will lead to scrap. And the same issue or same point we will find that also in the CableBuilder Enterprise, that you will have a comparison between version 0 up to version whatever 100, 200, 300. So it will be easily to go and compare what I have produced or what I've designed 10 years ago compared to today, compared to today design. Then we'll show you in this slide two examples. The first example is we have two drums or two orders produced well matching with information coming from CableBuilder or coming from the ERP, and the second one is a failure. So as you can see here, the green one is matching with or the actual thickness is intolerance between the lower thickness and the maximum target. The same for the second one, but the last one, if you see the actual thickness is 0.91, which is lower than the lower limit, which lead to failure. And here the system will tell you then you're producing something wrong and will stop you at this limit. And here in the second one is more focused about the kind of messages, kind of orders that the system will help you to control and stop at certain limit to not to produce or to go further for wrong production. And last but not least, if you want to authorize the system to go ahead with even violating the standard, it's up to you. Then you can continue. If not, then you can stop here and take a common decision that yes, we will go ahead, or we'll scrap, or we'll do rework in this part. The second one, I will show you a couple of examples for the material waste, or sorry, not for materials, for material handling and material management inside the factory. And I like always to start with metal example, because the metal example, or the metal itself is presenting more than 50% of the cost breakdown of most of the cables. So we start with the copper, and we have the polymer, metal, steel, and the expensive metal. Then we will see the flow of receiving the material and how the system will help you to track the material from the day that you receive inside the factory. First one, we receive the material inside the factory, then we will issue the barcode, and then we go to the visual inspection, and if the material is okay, then the system will allow you to flow the material to the next step. But if it's not okay, also the system will help you to do or to generate NC non-conformity to the supplier, and even to track all this non-conformity to the suppliers. And all of you know that how headache it is when you have the non-compliance of the raw material. Then we go to next one. The raw material will go to next step, which is a warehouse, and last point, which when the material is in the warehouse, then waiting for the order from the shop floor to issue a material to go to specific orders. One of the most important for us, and it's going to track from A to Z, from the first one until the material usage in the shop floor, which is a barcode. And barcode system will help us to track each and every gram that going inside, or that entered in the system and going inside the factory. And not only that, I want to give an example here. If you issue, for example, 1 ton PVC, 1 ton polymer to a specific order, and the order is going to use only 900 kg, so still 100 kg remain to go back to the warehouse, or to go to next order, or to next machine, or whatever. So with the system, you will even track all this remaining hidden raw material that we don't see it visually. Okay, this slide will show you a comparison between quality, performance, and availability inside the shop floor. As you know, if you go lower with the quality, you will produce scrap, and that will impact the performance of overall plant, and it will lead to non-availability of the machines. So the quality, when we focus, when we are talking meeting all today to talk about quality, we mean it, because the quality, when we improve our quality, or even we maintain it at certain level, will protect the other two parameters, which is the performance of my unit and the availability of my machines, which will lead to receive more orders and to maintain it at the good performance that we expected, as Amanda mentioned. That was my small presentation for today. Please don't forget that we will be together in Wire Düsseldorf end of June, and we also be together in Wire Expo 2022 in the States beginning of June. So we'll be more than happy to meet you in both exhibitions. And luckily, I'm in the Middle East. I know we are not talking to Middle East team, but I'm in the Middle East for a couple of days. I will be more than happy also to meet you and to book a few meetings. Thank you for your participation. And now we will move to Q&A sessions. We have received a couple of questions during the session today. We have received also a couple of questions in the past time. We are going to answer them now with the support of Amanda and Ben. Thank you so much.
Okay, so we have a few questions, but if you have any more, please just type them into the chat box. So the first question we have is, how can CableMES stop the wrong materials from being used? So I think maybe I can answer that one. So we know in MES we know what materials are required, what the bill of material is that is required for the product that we're about to make. And as Hamada has mentioned, every product that is coming into the machine, whether it be a raw material or an intermediate whip drum, it will have a barcode label on it. So first and foremost, we're presenting the information of what materials are required to the machine operator, and not just which materials are required, but also what's available and where it is and what the quantities are. So all the information should be there for him to select the correct material. When he then scans those materials, CableMES will check them against its list of what is required, and it will either accept them or reject them. So if we're trying to load the wrong material, then the system will let the operator know, and it will reject the material and not allow him to load that material into the system. Do we have any more questions?
I can take the how will the system know if a product is being manufactured out of tolerance. So if your setup includes devices on the lines that are providing data that are being collected by the system, then you would automatically start to see alarms as the product is being made. As operators finish their production, they can enter offline measurements, which can be recorded in the system against the work in progress item that they've just made. And equally, the quality department can also have access to MES and could also enter quality data, and all those people can put product on hold if it's out of specification, and alarms would be made available, and product wouldn't progress until it had been cleared by the appropriate authority within the factory. So that's how the system can be used in an online and offline manner.
Thanks, Bill. Okay. Amanda, can you take the third one, and I will take the fourth one because it's related to Nexans, and I have plenty of information about Nexans.
Okay. Another question is, how does CableMES report back to ERP? So one of the benefits of having such a system as CableMES is that even though the ERP system is sort of disassociated with what's happening in the plant, with the MES, we can actually report back and keep it in sync. So things that we most likely report back, we will report back when quantities are completed. We'll report back the amount of materials consumed. We'll report back things like running and setup times back to the ERP system. And we can also report back things like good quantities, bad quantities. So really, we will report back as often as is required. It could be every reel, it could be once a day, but the whole point is we will try to keep the ERP, the business system, in sync as much as possible with MES, so that it can do a better job for knowing when it needs to order new materials, or when it maybe needs to reschedule something based on what's happening on the shop floor. Okay.
Thanks, Amanda. Yes, I want to ask. I want to answer the one. I loved this. Have you implemented the full system at Nexans site that use SAP? The answer is yes, and not only SAP. Nexans are using different, or it's based on the unit. Some of the units are using SAP. Some of the units are using Microsoft Navision. And the answer to this question, yes, is fully implemented, and the integration is running very well with the SAP, Oracle, and Microsoft Navision. The three of the systems that I know is running very well, and I have my Hamada as a personal experience with those three systems.
Okay, we have one. Can you show us actual tracking of material? So I think for today we can't really show you this, but perhaps we can be in touch. I assume we know who's sending us this question. I can't actually see that, but we can be in touch and maybe organize a demonstration, and we can show you a proper demo to show actually how it all works and how the materials are tracked. So we can do that after this.
Amanda, can I add something here? Just to follow up this point. If you have any question that you don't want to share it with all of us, please send it individually, and we'll be in touch with you to organize specific demo for you to show you the full system, the integration between two systems, as well as the raw material tracking as you asked for.
Okay, we have another question. How can all these measurements be collected? Is it human? Is it written, collected manually or by devices? And the answer to that is it depends. So if you have the devices to collect the data, then we can connect through to them, then we can certainly connect it automatically from the equipment. Not every machine might have equipment that has these facilities, so in some instances we may be asking for a manual entry, but it very much depends what is available. But the default is if you can't collect it any other way, then we would ask for a manual entry. But if there is a more automated way to collect it, then we would be looking to do that.
We've now got an implementation question. How long does it take to implement this complete integrated system?
I can answer this one if you want, Bill,
Yep.
with the support of Amanda, because we had experience with the implementation. First of all, the project is not built as a grow project or as a big project. So we start with a target machine. So we for example, if we target only the extrusion lines, so we target the extrusion, and then we grow our system gradually. But we don't start everything at once, because first of all we need the resources, and resources is very important. Resources not only a manpower, resources also is a data that will help us to start the project in the right way. And resources also for CableMES, as I said, the most important for us is to have the right input to CableMES. If you want the high functionality of CableMES, then you have to ensure that you are feeding the CableMES with the right data. If you are sure that the ERP, your ERP, whatever ERP it is good in terms of data, then it's fine. But from our side, we highly recommend to have the CableBuilder as CableBuilder. We know that we are sure that the data inside the CableBuilder is 100% matching with what we want and what you want, and then the data flow between the CableBuilder and CableMES will be at least clear and clean. So Amanda, if you want to add something.
Yeah, I think I agree. I mean, when you look at what we're proposing here, it's something that affects the whole factory, especially with MES. It's going to affect the shop floor. So what we recommend is you do it in phases. So the timing of this is really dependent on you, how quickly you want to do it, how much resource you have, what equipment you already have. But we would recommend to do it in phases. And the whole point of picking how the phases flow is for the first phase, we're looking to see some benefit. So we don't want to wait till we get to the end to see any benefit. We want to start seeing benefits as soon as possible. So we would plan the project in a phased way, but that even after phase one, we're getting some benefits out of what we've done. So we would look at what your major issues are at the moment, what the problems are that would benefit you to be solved immediately, and that's how we would then phase it. So it makes it, if you look at the whole thing, it looks a massive project and frightening, but if you put it into phases with defined milestones, and then you're going to get something out of each phase, it makes it a lot easier to do, and people are a lot more comfortable with it, and it's a lot easier to start implementing it that way on the shop floor without causing any major disruption. Hope that answers the question. Can you add the QA QC, or do you need an extra platform? I'm not really sure what.
I think that means the QA QC function. So if QA and QC has access to MES, which they do, they could type in test results into the system against a particular WIP item. But I think this question might specifically be saying, could you integrate with test equipment to capture test results off test equipment so that that's automatically registered against the WIP? I guess that's just an interface. That's just an interface issue through Wonderware, is it?
It is, yeah, and we have done that as well in places as well, that we have results coming in automatically from pieces of test equipment. Yeah. So
the system enables us to integrate QA and QC actually into the process of producing the cable, rather than having it as a side organization with a side set of data, and they can put product on hold if they're not happy that it's the right quality, and it'll stop it being used. So they've got that authority. It's not just a red ticket on the drum. It's actually within the system. The operator wouldn't be able.
Just a moment.
I've got the slide. It's showing the Q&A.
The slide is okay?
We're back.
Is the accuracy of the system dependent upon 100% accuracy of the data entry? I suppose rubbish in, rubbish out is true for all systems. And yes, you would want accurate data typing in. Equally, what we want to try and do is to have as much digital data as possible coming into the system, because that would then eliminate the human error, the keying error. There was a question this morning, however, if an operator enters a value that is way out of range by accident, then it can be set up with an MES that the operator is asked, are you really sure you want to enter that value? And then they realize they've keyed something wrong, and then they can correct it. So there is some error proofing in terms of data entry from operators.
I think we also try to make it so that it's not a complex system to use. The screens are very simple. So, okay, anybody can type the wrong number in, but, you know, it should be very intuitive to actually know what you're doing at any time. And also, if something has been entered incorrectly, it's also then possible to change it, you know, to update it, to correct it once the error has been spotted, so that everything doesn't get messed up from there on.
I'd suggest that the question around the Nexans plant is something that Hamada should address privately with whoever has asked the question, as it's commercially confidential as to which Nexans plants are using what. And we've got a wide audience on the call today, so I'm sure Hamada will be in touch with that person.
I will be in touch with the one who asked this question, and I will guide him which Nexans unit are using what. I do believe it's a little bit confidential, but it's okay. Well, I'm telling you from my experience with Nexans that some units that are using Microsoft Navision, and this integrated very, very, very well. And one of those units, the one I used to work as a technical and R&D director, and other units are using SCP, and mainly they are located in Europe. But I will be in touch with you to share with you more information about how the implementation or the integration with the ERP is working in Nexans and with other clients as well.
Can
Well,
cable?
Amanda,
Mhm.
please, Bill, go ahead.
We've got a question. Can CableMES manage scrap produced as an inventoried part number? Not quite sure what that means. We would be recording scrap against each production order that we're manufacturing, so we would know which order the scrap was manufactured on. Equally, through traceability, we would then know which batches of raw materials had been scrapped. And as the question raiser is saying, there is obviously a real resale value on good, clean aluminium and copper scrap. Usually you can get 90% of the metal value back against the LME price. So you can recover a lot of the metal price, but obviously you can't recover the added value that you've added to that metal during the production processes. So yes, you can. If you were scrapping 0.1 fine wire multi-wire, which has had a huge amount of value added to it to get it to that state, you would only get a fraction of the cost back, although you would be getting most of the metal price back. I think I've answered that question.
So we've got a few more questions coming through. So I'm just going to go through the top. so they're as they come through. So one question is, do you include the cable reels at the material management? So the answer to that is yes. So when we've been talking about WIP is effectively the cable reels that are going from, manufactured, end up on the end of one machine and then feeds the next machine. So yes, the cable reels are included in material management. Does CableMES
Sorry,
go on. Make provision for connection to auxiliary test equipment? So yes, it does. So through the IoT platform. So CableMES itself is not connecting directly to PLCs or drives or any test equipment, but through the IoT platform, we typically recommend Wonderware, but there are others that can be used. This has device drivers generally to connect through to any piece of hardware on the shop floor. So if there's a driver already available, we'll be able to connect through that and access the data. If there isn't a driver available, then there is always a way to make one. So the answer is, in general, yes. If there's anything very specific that you want to talk to us about, then perhaps we can have a meeting after this meeting to discuss what particular pieces of equipment you're wanting to connect to. Okay, next one. Can you configure CableMES so that material management is done in ERP? You can. All the bits of MES we've described today, you can kind of turn them on or off. So you don't have to use the whole system all at once. You can start small and get bigger. And to be honest, with material management, it's normally a bit of both. So because the master for materials is always your ERP system. That's ordering them, that's storing them, if you like, in the warehouses off the shop floor. So the master is always the ERP. What generally happens is when products are to be produced, they will be released from ERP to MES. MES will then track them through manufacture and then return them back to ERP when it's finished with the quantities that are left. So you can have a bit of mix and match, or you can do. You decide where the barriers are and which system is responsible for which. So yes, the answer is yes. It is possible to do more in ERP with material management. Where are we now? Next one. How do PLC and machines provide the correct feedback? Again, that's a little bit like the answer to the last question. Through the IoT, we can connect through to any parameter, any process value that is being, that is being captured through the devices on the shop floor. So, and it's kind of configurable. So in CableMES, it's not fixed at all. You decide in the configuration of the tool which parameters you're interested in. First of all, downloading. So if you want to download a recipe, when you start running a product, you start that job, if you want to download a recipe, you configure which parameters that are associated with that product that have come from CableBuilder that you would download through the IoT that go to the PLC and ultimately to whichever device needs that parameter. And then conversely, you also configure what information you want to read back. So it's all configurable. It's not fixed at all. You set it up by process type, which parameters you're interested in, and it's all done through the connectivity that the IoT platform gives us. Hope that answers the question. I might give this one to you, Bill. How does the system understand and reflect the balance of material in each process?
I knew you were going to do that. I knew you were going to do that. I don't actually know the answer to that question because it's quite a tricky question. That over time you may start off with some bulk materials, for example, behind an extruder, and you consume that batch. You could consume that batch over a number of orders, and I think the answer is actually that it's not done necessarily order by order or length by length, comparing back to the bill of materials. It would be done over an accounting period or over a period of a week, where you would eventually account for your materials and compare the materials consumed with the theoretical materials produced. And you would have a variance. It could be positive, it could be negative. And I would hope that you'd recorded sufficient information about the quality of the products and the size and weight of the products that have been produced that would enable you to show whether variances has occurred. So it wouldn't be necessarily order by order, because you don't obviously weigh a drum of cable as you make it. It would be derived from its parameters.
Thank you.
What is the recommended platform to integrate with MES? Downwards and upwards, I guess.
Yes, I mean, in terms of the ERP system, it doesn't really matter. Downwards, we would recommend Wonderware System Platform, because we know it, we've tried and tested it, and it's a very, very strong, solid platform with the integration to, I think it's got, thousands of the devices it will integrate to, and the Wonderware support is very, very good worldwide. So we would recommend that one, but it's not to say that's the only one that is possible. How much is the system affected by human errors? So that's quite a good one, actually.
How much is manufacturing affected by human errors?
Yeah,
a lot, I would suggest.
Yeah, the thing with CableMES is there is things built in to try to avoid human errors. So if something is about to fail quality, we will there'll be lots of, are you sure that this is this is what you want to do? So there are things in there to try and avoid human errors, but human error will always be a human error. I think with the system as well, we tried to make it very simple. So the screens are quite simple, easy to use. So it should be quite intuitive, that it's not confusing, it's straightforward. It follows the process of what you're doing when you're manufacturing the cable.
Do you have ranges where if an operator tries to enter a parameter that's so far out of range that it just won't accept it? Like trying to type in 1,000,000 meters instead of 100,000 meters.
Yeah, you can have ranges, and it will certainly flag up that, are you really sure that this is what you want to do? But I think the thing is as well, because once an error has been made, that there are going to be errors made, you can't avoid it. But then there are methods in the system as well to correct it. So once the error has happened, once it becomes clear, that wasn't really 10 millimeters too big, you can actually go back and correct it and get things back on track.
How do you control the copper batches through wire drawing process? How do you control the different barcode batches through the wire drawing process? So again, this is a bulk material question. We could be starting with copper rod, going through a breakdown machine, and you would be recording for each batch of, you'd record each batch of rod going in, and when it went in, and it would be timed when we started to use a particular length of rod, and we'd know within the time period the wire that was made from it. So you'd have that traceability back through a batch code and through time, and that will be true of many of the production processes that are drawing down bulk material. So I think that's, and in terms of, you can, I know, have different qualities of rod. That's not necessarily always the case, but there are different qualities of rod, and you might only want to, for example, use a very high quality rod for 0.1 millimeter wire, and potentially a lower quality rod for sort of 0.4 or 0.5 millimeter wires. So again, that's just starting to categorize. The raw materials would be a different raw material code, and you would only be able to use the higher quality raw material code to produce the higher quality wire. That's something that you could instigate. So I think that probably answers that question. I hope it did. Can you report for scrap percentage per order? If you've got all of the material in all of the data within the system for the components, the final cable and the subcomponents of that cable, then yes, you could produce a scrap percentage for an order. If it was specific, if it was a special cable, you would be able to do that very easily. If it's a commodity cable, that would be less easy, because obviously you get shared components going through in a commodity cable factory. What support will CableMES provide for planning?
So in terms of planning, CableMES starts from, if you like, it expects to be provided with a schedule that has had some logic applied, you know, that to meet the delivery dates for all products going through the factory. Once that schedule is into MES, then what we really look at it is, what you're doing then is kind of localized planning. So for each area, then there are many tools to help expedite work through that area to meet the schedule that we've been provided. So you can do things, you can resequence things, obviously. You can batch things together in what we call a machine run, so that, you know, if you've got two similar orders following each other, you can batch them into one, so when it gets on the shop floor, it's just you know, make 4 drums of this rather than make 2 drums and then 2 drums. You can change machines. If one machine's broken down, you can change it to another machine. You can split an order. So if you get an order for, I don't know, 4 reels of some particular drum that's scheduled to be run on machine A, if you want to expedite that through quicker, you could split it and run 2 drums on machine A, 2 drums on machine B, and CableMES will sort out everything that's happening in the background to make sure the data reporting back is correct, and it also gets sorted out in the background. But really, MES is not a scheduling tool, but you can do a lot of things, you know, to expedite and change things if things have gone wrong, in order to move work around within the system itself.
I think you've partly answered the next question. I think you've partly answered the next question now, Amanda, which is, in order to reduce the WIP, does CableMES run a value stream mapping algorithm in order to minimize the bottlenecks? And as you just said, MES isn't a scheduling tool. However, the information that is provided by MES will show very clearly the level of WIP that exists behind each process. And I'm guessing somewhere, either in MES or in the ERP, you could set some alarms around the volume of materials that exist in a particular WIP bucket if you wanted to do that somewhere. That would either show that a level of material was too low or too high. I'd guess it might be in the ERP system, it could be in MES. I think that would be a new requirement. Is that right?
Yes, yep, most definitely. Yep. What do you mean by losses in availability? I think that must be referring to Hamada's presentation. I'm not sure his connection is good enough.
So that's an OEE question. So that is, for example, if we have a changeover that should take an hour, we'll lose an hour. But if it takes an hour and 10 minutes, then we've had an unexpected loss of availability. So you can, OEE, as always in my world, you can have a gross OEE and a net OEE. And the net is something that's enables production to measure itself against its standards. So if a changeover is supposed to take an hour and it takes an hour, then that's fine. We will have an accepted loss of availability. And we might say that our availability target is, say, 90% or 80%, something like that. If our availability falls below that, we want to be able to investigate where we've had additional losses. So it could have been a breakdown, it could have been a changeover that took too long, it could have been a quality problem that meant that we couldn't start producing good quality product when we expected to in a startup, which would have lengthened the changeover time. So there are many aspects of loss of availability, but I think those are two examples that may help the questioner to understand loss of availability. How would you handle two different bulk batches used for extrusion, one after the other, Amanda?
I'm not sure what that question's actually.
I think it means if I've got batch one of some PVC that I'm running, and then through the run I then have to open a second octobin to start feeding material in for during an order. How do I record both? That I've used both batches of PVC on this particular cable run.
Well, it does get a little bit complicated, this, but first of all, you would allocate. We know how much is in the first batch. We'll have a quantity for it, so we'll know when we've produced a certain amount of cable that we've run out of material, or we should have theoretically run out of material in that first bulk batch. So we will know that. So we will then ask for, before you can report progress that you've finished your next reel, we'll say, but you must have used some more material, give me another barcode. So we would ask for another barcode to be scanned. It can get more complicated, because sometimes when this material is being shared by many machines, and it can be, blown through, so many machines can be consuming the same batch at the same time, that again, we can have what we call shared materials that can be consumed by many machines at the same time. And again, every length that is made everywhere will be consumed from that batch, and we will know when theoretically there's none left and we need a new barcode. She must be using a different batch now. Hope that answers the question.
The next one's one for me. What should the standard scrap percentage for the plant having all types of products in portfolio and manufacturing 200 plus designs in a month with 22,000 cable kilometers produced in a month? So this is
the answer to that.
I'm going to come up with one. This is obviously a complicated factory, because it's producing about 10 different cables a day. It's doing them in quite high volumes, but it's doing quite a variety of cables. I don't know whether it's got shared components for those designs or not, or whether they're all unique. But I would say that you should never have a scrap percentage greater than 5%, and that in this environment, if you were producing with scrap of 2% or less, you would probably be world class. I hope that answers the question. That's a personal opinion based on the information that the questioner has provided. Yeah, they are allowed to disagree.
I think it's a good answer.
Thank you very much for giving those answers, Bill, Amanda, and thank you to Hamada as well. I think that's all the questions we've had. We've had lots of questions today. Great to see those questions come through, and yeah, thanks to you guys for taking the time to answer them. So we've come to the end of the webinar. We trust you've enjoyed today's webinar and have seen the many benefits that CableMES can bring to your operations, specifically in scrap reduction and material management. You'll receive a follow-up email from us later on today, which will include a recording of this webinar, so please look out for it. If you'd like to discuss anything or see a demonstration of CableMES, please reach out to Hamada Khalifa at hamada.khalifa@cimteq.com. I'd also like to draw your attention to the fact that Cimteq are exhibiting at the Wire Expo in Dallas in June 7th and 8th, and at Wire Dusseldorf between June 20th and June 24th. If you are at either events, please do visit us. If you'd like to book an appointment to meet the team, please email info@cimteq.com and we'll get you in touch with the relevant salesperson. We thank you once again for joining us today, and we hope to see you at future Cimteq webinars. Thanks again.